multiple step or multiple design as well, right? So one particular diagram we have shared. In that diagram, or in that basically block diagram, or again it is a conceptual diagram which basically draw or outline the different steps involved in system design. I'm not saying only database design, right? So whenever there is a real world system needs to design, the very first step we have discussed that it will be the collection of requirements. So collection of all kind of requirements, right? So whenever we are going to design a system, we will be asking for the requirements from a customer, or from from a client, or from anyone who is having basically the request to design a system. So the first step is to collect all the requirements naturally. So there will be two individuals sitting for that, or there will be two teams sitting for that, and they will be collecting all these possible requirements, right? That was the first step. So whenever we are designing a software system, the first step is to requirement engineering, which involves requirement collection and requirement analysis, two parts, right? So requirement collection means you can simply organize a meeting, or maybe you can simply organize a case study where you can discuss about all possible uses of the system. The system banne wala hai, right? After noting down all those 100 or maybe 1,000 requirements, you will be analyzing that what is the feasibility of each requirements, which two requirements can be clubbed, or which two requirements can be eliminated, or anything like that. So second step within the requirement engineering is requirement analysis. So after performing or conducting these two steps, these two internal steps of requirement engineering, we will be writing or noting down all those finalized requirements, right? So you will be noting down all these requirements in a document which is referred as a SRS, right? Which is system requirements and specifications, right? So you will be preparing, or maybe person who is coming from the organization जो develop करने वाला software का. So there will be one or two person of maybe team which will be recording each and every instruction, each and every requirements into the SRS. Now, after getting this requirement done, this document done, we will be sharing this SRS with our designer team, right? Designer team will basically read these all instructions, and they will try to develop the first impression of the system. That's why we are saying this second step is called design step, and reference to database. With respect to database, it is referred as a conceptual data design, because from the SRS, where we have kept all the requirements, we take out the requirements which will be helping you to design a database aspect of the system. Front end wala means, except this database aspect of the system, they will be having other teams which will be designing the interface on other aspect of the software system. But our focus in the class is to discuss the database. That's why we are basically highlighting that there will be a separate design, separate data design, separate conceptual design, which elaborates the database aspects, right? So basically all those data requirements will be separated or extracted from the SRS, and will be shared to the person who is called a database designer. Now, there are very few individuals in the organization, a software organization, which will be responsible for creating these kind of representations of the same text requirements which are written in the SRS. But they will take out all the requirements which are specifically important for the database design, right? So one example we will discuss in next 5 to 10 minutes, right? So in the very first step is called conceptual design, which asks you, or which provides you the information or detail about the system, which will be helping you to design the database part, right? So during this conceptual data modeling phase or step, we will be drawing some kind of representation of the system, right? So these conceptual data modeling will help you to understand the possible maybe tables, because अगर हम इस database इस तरीके से समझें कि database table ही बनने वाले हैं, so the first thing we will understand that what are the possible tables we need, what are the possible attributes we will be plugging into, what are the values primary thing will be there, what are the dependency between two tables, right? So all those things will be drawn into the conceptual data model. That's what a database designer will be doing, right? He will be reading all the instructions, all the requirements, data related requirements, and mapping these requirements into a conceptual data model, right? So the very first imprint or the version of data modeling, conceptual data modeling could be a flow graph or flow chart also. So because with flow chart we have a lot of familiarity. So flow chart kind of diagrams are considered as a conceptual data model. So there are various diagrams available. So if you explore, there's a course called UML, Unified Modeling Language. So that course or that syllabus of the course is designed to understand that what are the various possible modeling diagrams we can have. तो जब आप सॉफ्टवेयर इंजीनियरिंग पढ़ेंगे नेक्स्ट सेमेस्टर में, फोर्थ सेमेस्टर में, so there is the use of various diagrams, because like we have started today, so after getting the SRS done, there are different teams who are designing these diagrams. So for database you need to design only one diagram, but for other aspect of the system like front end, module to module, different modules, different parts of the system, you need to design various other diagrams, conceptual diagrams, right? So primarily there are around 100 diagrams or 118 diagrams, conceptual modeling diagrams, but out of these 100 or 118, primarily there are only 27 diagrams which are used to design the different aspect of the system. I'm saying system, not database system, right? So to design the conceptual data model of a database, or for the database, we will have one kind of diagram specifically, and it is called entity relationship diagram, which is called ERD, right? So ERD is the focus of maybe next 2 or 3 lectures, and today we will be touching upon the few basic elements of the ERD and why these elements are important, and how you can identify that these are the possible elements of a given requirement. So because eventually a database designer will be getting these all requirements in the text statement form. Now he has to identify those specific elements, and then he has to map these elements or these information into a diagram, right? And this is called somewhere it is referred as a visual data modeling, a visual modeling of the system, right? So it is important. So whenever, as a problem solver, as a computer science student, whenever we are planning to design a system, it is almost compulsory and it is almost recommended that you have to design a visual impression of the system, right? Conceptual model. So conceptual model is nothing but it is a first version or first impression of the of your software system, right? So that's why we often refer, whenever you are writing an algorithm, you have to draw a flow chart, or maybe you have to write a pseudocode, right? So these intermediate representation will provides you the better understanding of the same system, right? You can directly implement a system also. That is also I don't know. It is not prohibited. You can after reading the instruction of the problem statement, after reading the requirements, you can directly create a system. It is not restricted. You can go for that. But whenever we will be designing a complex system means it will have multiple computing portions, and the computing portions are interleaved. So whenever we are having this kind of requirements, where multiple possible modules are there, and these modules are interleaved and they are interacting with each other by sharing various information and control, you need to create, or you need to have this systematic approach of creating conceptual data model first, then you can directly map this conceptual data model into a logical model. Logical model means it is the actual implementation. So after designing this conceptual representation of the system, the next step is to mapping this conceptual representation of system into the actual implementation or actual design, right? So after conceptual, there is a logical mapping, and after that there is a physical data modeling. So eventually we have involved only 2 steps while designing the data modeling or while designing the data base. So that first is conceptual data modeling, and second is logical data modeling, right? About the physical data modeling, DBMS will take care of each and everything, because he's having a lot of automated modules, automated computing parts, which will take care of all the other activities as physical data modeling. Now, our focus is to understand, because for data conceptual modeling, we need to have some kind of familiarity with the data modeling diagram or elements of the diagram, right? So the diagram which we refer to is useful to create the conceptual data model is often referred as the entity relationship diagram. Entities, we have taken this term during the first three lectures somewhere. Entities are nothing but it is a real world maybe object. Object term is quite similar, familiar with we. So anything which is having its presence on the real world. So it can be an individual, it can be any event actually which is happening in the real world. So because the whole purpose of maintaining a database is to capture the presence of anything, any individual in the real world into the system, capture the detail of an event which is happening or which happened in the real world into the system to achieve some operations on that recorded details, right? So that's what entity is the first thing which needs to be captured. जब भी आपका written a requirement given है, so the first thing you have to identify which are basically possible entities are there in the requirement, right? That is the first thing. Naturally, अगर आप entities को identify करेंगे तो हर entity का attribute होता है. Like in our case, as a human being, we are having some attributes, and based on that, those attributes only we are able to recognize in the real world. And if you want to create the representation of an individual, it is important to capture its attribute. कि उसकी height क्या है, age क्या है, तो उसी सब चीज से तो आप establish करेंगे ना सिस्टम में, आप उसको मैप करें किसी इंडिविजुअल को. किसी इवेंट को भी अगर आपको मैप करना है डेटाबेस के अंदर, तो इट इज देयर एट्रीब्यूट्स. लाइक अगर ट्रांजैक्शन हुआ है तो व्हाट इज द टाइम, व्हाट इज द डेट, व्हाट इज द मशीन आईडी, व्हाट द ट्रांजैक्शन नेचर, how much amount has been done. So likewise, so for each and every entity, naturally we have to capture certain attributes. It is important, I think. So after capturing these two, think first. So first is entity, capturing entity. Second is identifying its attribute. Second, third thing is relationship, right? Because if we are saying there we will be capturing different entities of a certain requirement or certain scenario, all entity must not have relationship like a kind of mesh topology. ऐसा नहीं कि हर entity का हर entity के साथ relation होगा, but there must be some kind of relationship between entities. Like students are related to courses, teachers are related to the departments, faculty are related to department in some way, and teachers are also having some kind of relationship with courses, right? So likewise, whenever we capture or whenever we model the entities of a requirement or maybe of any scenario, it is naturally observed that there must be some kind of relationship or some kind of relatedness among these entities. So let me take 5 seconds to share our document, share our notes of the class, where we have written a small requirement, right? वो पिछले आपके notes में भी थी, but now I have so this is what I am talking about. So we have is it visible? Can you confirm with audio? Anyone?
Yes, sir.
Yes, sir.
So okay, so let me zoom it a little. So this is what we have discussed in the previous class, this flow. So from mini level to this, and for this conceptual design level, we need entity relationship diagram, which is referred as ER diagram. Now, if you read this requirement, this is what we have written in the previous lecture notes also. So there are a very small requirement which says that you have to design a database. A database is being constructed to keep track of the teams and the games of a sport league. A team has a number of players, not all of whom participate in each game. It is desired to keep track of the players participating in each game for each team, the position they played in that game, and result of the game. Now, you can assume any sport for that, right? But this is the kind of requirements we will be taking out from the SRS, because these all informations, these are details will be helping you to model a database conceptual diagram, right? So I hope you are able to at least identify the entities from this direct requirement. So I can, okay, there are some underlying terms also, so you can understand that team will be the first entity. क्योंकि एक इवेंट होगा तो उसमें एक टीम होगी, राइट? टीम इज ए रियल वर्ल्ड एंटिटी, और टीम के साथ प्लेयर्स भी होंगे, players. So you can have क्योंकि teams means, why we are defining teams as an entity, because there will be various different participating teams we have, and for each we will be defining the groups. So teams are like groups are nothing but it is similar kind of object. So team is the first entity. You can have games are also having some kind of entity, then we have players also. So there are three entities clearly visible from the requirement, right? So बहुत सारे students पूछते हैं कि sir, how to identify the entity? Are these are the three only possible entity for this this requirement? No, it is not like that. So whenever you are going through a requirement, there are some possible entity which will be clearly visible to you, right? But there are some other entities possible which will be coming from the requirements which system will be delivering. जो सिस्टम वो अचीव करेगा. तो अगर आप इसको रीड करो सेकेंड सेंटेंस ऑनवर्ड्स फ्रॉम हियर टू here it is clearly visible that this is the part system will be delivering. What is the objective of the system? That's what this statement is saying. It is saying it is desired to keep track of, so it is desired that system should be able to keep track of the players participating in each game for each team. That is the first thing system should be able to track. Second, the position they played. So the position a player played in that game. That is what is expected from the system, and result of the game. Okay. So whenever you are identifying the entities of the system, few entities will be written out somewhere in the requirement, but few entities will be coming from the part of the requirement which requirement should be delivered by the system. तो ये आपको प्लान करना पड़ेगा कि इट डिपेंड्स ऑन कि आपकी अंडरस्टैंडिंग कैपेबिलिटी कितनी है सिस्टम की. तो आप 3 टेबल क्लियरली बनाएंगे टीम और गेम और प्लेयर के लिए, बट अगर आपको ये ट्रैक करना है कि किस प्लेयर ने किस गेम में पार्टिसिपेट किया, क्योंकि हो सकता है कि एक टीम में 12 प्लेयर हो बट खेल सकते हैं केवल 11 खेल सकते हैं, तो एक तो नहीं खेलेगा. सो दैट्स व्हाई इट इज इंपॉर्टेंट टू हैव आइडिया कि अगर एक टीम ने 4 या 5 गेम खेले हैं तो उन हर एक गेम्स में किन 11 प्लेयर्स ने खेला. सो ये हम कभी भी ट्रैक कर पाए. दैट्स व्हाट सिस्टम इज आस्किंग फॉर. सेकंड, if game is football, one player can play in a different position in a single game. So you need to have some kind of, either you will be creating a separate entity जिसमें आप ट्रैक करेंगे कि इस गेम नंबर 1 में प्लेयर नंबर P11 had played in these 4 positions, something like that. So either you need to create a separate table or entity, or you have to create this information into some entity. या तो आप पहली 3 एंटिटी को लेके ही चले, उन्हीं में कुछ एट्रीब्यूट्स प्लग कर दें, या तो आप इन रिक्वायरमेंट्स को मीट करने के लिए जो सिस्टम डिलीवर करने वाला है, you can have separate entity also. That's up to you. It is up to the knowledge, the idea of a database designer. So here we are working as a database designer. Now it is up to my wisdom, it is up to my knowledge, experience, that I can go for approach B, where we have 3 basic entities: team, player, and game, and there are 3 different entities to keep track of these given system requirements. So we'll have probably 6 entities. Right, that's one part. Second part, so we have done with tables or entities. Now we can identify the attributes. Attributes are nothing but, in case of player, you can have entities like player number, player name, player height, and all those possible attributes which are required to be there in the database. And relationship, naturally. So because team and player and game, so we have to draw a relationship between all these 6 possible entities, right? तो ये हम समझेंगे कैसे करते हैं, बट दिस इज द वे वी हैव टू डील विद द रिक्वायरमेंट्स. दिस इज द फॉर्म वी विल बी राइटिंग द रिक्वायरमेंट्स। एसआरएस सेलेक्ट करने के बाद इस फॉर्म में रहेगा, इसको आपको रीड करना है और उसमें से आपको एंटिटीज आइडेंटिफाई करना है। एट्रीब्यूट्स से मेंशन नहीं है, बट यू कैन क्रिएट द एट्रीब्यूट्स। बट आइडियली जब आप देखते हैं एसआरएस तो उसमें एट्रीब्यूट्स भी लिखे होते हैं कि अगर बैंक का आपका सिस्टम बनाना है, बैंक का डेटाबेस बनाना है, तो उसमें लिखा होगा कि कस्टमर विल हैव all basically his name, his DOB, his all kind of things. So जो आप बैंक में अकाउंट क्रिएट करने के लिए फॉर्म भरते हैं और जो इन्फॉर्मेशन देते हैं, those other informations are basically being used as a attributes of yours, right, as a customer or as a maybe individual person, right? So यहाँ पर हमने नहीं mention किया, but ideally there should be some kind of description की person will have this kind of information and team will have this kind of information and game will have this kind of information, game number, game place, game date, and who is the winner of the who was the winner of that game, who is the loser of that game, something like that. So you can add all those kind of attributes, and eventually at last you will be adding some kind of information to understand that these two entities, player and team, are having relationship. So you can have player has team, something. So you need to draw a relationship and you need to define the relationship. What is the definition of that relationship? तो जब भी आप दो एंटिटीज के बीच में रिलेशनशिप डिफाइन करेंगे, try to track or try to take a word from the requirement itself कि दो टीम्स कैसे स्टेटमेंट फॉर्म में किस तरीके से रिक्वायरमेंट लिखा हुआ है कि टीम हैज अ प्लेयर। सो ऐसा हो सकता है कि रिक्वायरमेंट डायग्राम में, रिक्वायरमेंट स्टेटमेंट में ये लिखा होगा टीम हैज प्लेयर्स, गेम इज प्लेड ऑन दैट। So you can directly take a keyword or word from the requirement and use to define this relationship between two entities. So suppose we have this player this side and we have team this side. So you can have players like that, players from this team, or team has a player, something like that. So you can define a relationship between these two or any entity, right? So this is the way you can. So there are three primarily. There are three elements of ओके किस पॉइंट पर था मैं डिस्कस कर रहा था? कैन एनीवन कंफर्म सो दैट वी कैन डिस्कस? सो अभी ऑडिबल हूं मैं? यस और नो? Yes or no? Yes. Okay. So let me share that tab again, because now we are getting into the details. Okay. So this is what basically I was sharing. I will try to share. So there are only three possible elements. So entity, attribute, and relationship. Right. So entities are what? It is that it is basically anything which is having some existing significance in the real world, right? So it can be anything, person or event or anything, which will be written in the which will be mentioned in the requirements. Now there are possibilities that there are two basically instances or two types of entity. ऐसा नहीं है कि जो entities हैं वो सभी हमेशा कंपलसरी, लाइक अगर आप ऐसा समझो कि आप एक इंस्टीट्यूट और एक कॉलेज के लिए डेटाबेस क्रिएट कर रहे हो, सो वहां पर बहुत सारी एंटिटीज ऐसी हैं, ऐसी ऑब्जेक्ट्स हैं जो आपको हमेशा विजिबली दिखेंगे, उनकी सिग्निफिकेंस है, उनकी इंपॉर्टेंस है, बट और कुछ भी ऐसी एंटिटीज रहेंगी जिनकी सिग्निफिकेंस या जिनकी एग्जिस्टेंस दूसरी एंटिटी पे डिपेंड करेगा, एग्जिस्टेंस पे ही। जैसा कि एक एग्जांपल ये हो सकता है कि लाइक स्कॉलरशिप। सो suppose you are maintaining the records of scholarships also, right? Scholarships हो सकता है कि placement detail हो सकता है, so there are various other things are also. So scholarship का जो database table है, it will not be basically applicable, or maybe it will not be, okay, इस notes को close करते हैं, it will not be basically applicable to all students, राइट? सो एक पॉइंट में तो हमने सभी स्टूडेंट्स का डेटा रखा हुआ है, ऑल द स्टूडेंट्स, बट देयर इज नो नीड और देयर विल बी नॉट अ मैंडेटरी मैपिंग विद दिस रिलेशनशिप और मैपिंग विद दिस स्कॉलरशिप टेबल. तो देयर आर सम स्टूडेंट्स हु आर नॉट हैविंग अ मैपिंग विद दिस स्कॉलरशिप टेबल, राइट? सो इट इज बेसिकली लाइक दिस वे कि वीक एंटिटी वो है जो जिसकी एग्जिस्टेंस जो है किसी दूसरे पे डिपेंड कर रहा है. सो एग्जिस्टेंस ऑफ द स्कॉलरशिप एंटिटी डिपेंड्स ऑन द एग्जिस्टेंस ऑफ स्टूडेंट. सिमिलरली प्लेसमेंट वाला डेटा है. सो इफ यू आर कैप्चरिंग द प्लेसमेंट डिटेल्स ऑफ अ स्टूडेंट, कौन से स्टूडेंट किस कंपनी प्लेस हुआ है, सो द एग्जिस्टेंस ऑफ दिस प्लेसमेंट एंटिटी और प्लेसमेंट डिटेल डिपेंड्स ऑन द existence of the student. So in case of college database, there are these 3 or 4 entity which could be considered as a weak entity, right? Courses तो रहेंगे ही naturally. Courses does not need any basically existing or क्या कहते हैं इसको, it cannot be a weak entity basically because it does not need the definition of some other entity to be there. Courses are basically defined in the system and they are available there, right? So there are various systems where we have certain kind of entities which will be depending on the other entities. So ऐसा है कि हर database में there are various possible entity which could be a weak entity, but ऐसा आप मानो कि it is not a compulsion to have a weak entity. ऐसा नहीं है कि जब भी आप database create करेंगे तो weak entity होना ही चाहिए. It is not necessarily required, right? It depends on your understanding of the system कि आप उसको weak करना चाह रहे हैं कि strong. So what is the difference and why we are saying there is a weak, there is a strong? So strong means the entity which are written in the requirements as a directly, right, or maybe part of functional requirements, and weak entities are the entity which are basically coming from the database designer's understanding of the system. And he assumed that there are various entities which will be depending on those first level of entities, strong entities, right? तो इसको हम जब एग्जांपल लें कोई तो क्लियर हो जाएगा आपको. अभी जो हमने एग्जांपल लिया जो इसमें प्लेयर टीम और गेम था, there we cannot have any entity which will be acting as a weak entity, right? अब अगर आप सोच सकते हैं तो it again depends on your knowledge of the domain. It depends on you, right? Secondly, so we have done with entities. Entities are objects. They are referring to a real world object, real world, anything which exists in the real world, and there are 2 types of entities. One is strong, one is weak. Weak entities are entities which will be depending on a second strong entity, right? So that's what about entity. And to represent it in a diagram, we will use simple rectangle box. So anything like, suppose in a case of college database, student is entity. So we will write student, and then there is a rectangle box. So we will be writing each entity name inside a rectangle box. That's what we will be using to represent a entity, right? And suppose in this college itself there are some entity which are weak. To represent weak, we need double rectangle box, right? And so there is inside there will be the name of weak entity, and then there are two rectangle boxes. So this is what about entity. Now second thing is attributes. So attributes are interesting. So attributes are nothing but it is a property or the different aspect of a entity. So basically you can assume that there are the possible different types of attributes. So for an entity there could be different attributes. There are attributes which will have only single value, like your name. There is a single name of individuals. There is a single name of any student entity or any faculty entity. Even for courses also we will have only one name, right? But for, let's say about book. So for one course we can have multiple books. For one book we can have multiple authors. So for any entity there could be some attributes जिनकी एक value होगी. Those are called single valued attributes. There are various attributes which could have multiple values. Like in case of the student, I will have two phone numbers of the students. So those attributes which could have multiple values, phone number, addresses, and other things are there, various things are there. Those could have more than one value. So those kind of attributes are referred as a multi-valued attribute, right? So these two are the main types of attributes, single valued and multi-valued. So to represent single value, we will use oval shape representation, single oval shape. But to represent multi-valued, we will have two oval shape objects. Like in the case of weak entity, we have two rectangle box. So these things are written in the document, today's lecture notes also. So multi-values are the attributes which will have more than one value for the same single object or instance of object, right? So for a student, we will have name as a single value. His DOB is single valued, right? His father name is single valued naturally. His mother name is single valued naturally. But we can have multi values at email ID, phone number, address, other things also you can think, right? Probably. So जैसे आप कोई भी फॉर्म भरते हो तो कई बार वो दोनों एड्रेस पूछता है, दो फोन नंबर मांगता है आपसे, मल्टीपल अल्टरनेट आईडीज पूछता है, ईमेल आईडी. सो these things are maintained into multi-valued attributes, right? There are other attributes which you can derive. Like in case of student, I can derive the age. So when you enter the date of birth, I can estimate the age, right? So based on the provided information on date value, you can estimate the age of a student. So these kind of attributes are referred as a derived attributes, right? So these are three primary classification of attributes. So for any entity, whenever you design a database, you can have different attributes, but there are three main types of attributes you can have for entity. And for these three different type of attributes, we will have different kind of representation, right? So like for representing the single valued, let me open again the document. So okay, where's the document? Yeah, so here it is. Okay, so I think it is visible. So attributes under attributes, basically we have single value, multi-valued, and derived. So for single value, we have this kind of simple oval box. For multi-valued, we have this kind of double layered representation, and for derived, it is dashed oval, right? That's all the simple representation, right? So these are the three representations. So based on the nature of the values possible in the domain of the attribute, you can easily identify that for this entity, these attributes will be single valued. So let me use this single oval shape, and these are few attributes which will be having multiple values. So let me use this double oval shaped object, and उसके अंदर आपको attribute का नाम लिखना है. So there will be oval box, and inside it there will be a name of attribute which is like name, his father name, his mother name, right? His DOB. But in case of multi-valued, you can have this box representation and mention it like address, phone number, and his what is your email ID, something like that. So it is assumed that in the system, these possible attributes will have multiple values, right? So then, and for derived, we will use using this dashed line. It means that this value will be deriving, or it will be derived from somewhere else by using some value, some other attribute value, right? So I hope attributes are clear now, right? Now we are going to the third aspect of ER modeling, which is called relationship, which I am saying that it is the most important part of the ER diagram, because whenever we are drawing or defining or designing a database, the relationship is something which basically captures the most important aspect of the system, right? Because it is the relationship which describes the dependency of the object in one table with object in the other table. कि किस proportion में data में entries है, किस ratio में relationships define है, right? तो एक अब इसमें क्या है कि it defines basically the relationship. Okay, definition is not correct. I will be rectifying it and उसको मैं ठीक करके आपको share करूँगा. So there are basically 4 types of relationship, right? So we have 4 types, primarily 3 types. 1:1, 1:m, m:1. So these two are same. These two are similar. Just the size has been changed, and m:n, right? And to represent relationship, we have this diamond box object. So whenever we are drawing a ER diagram, we will be using this diamond shape to represent the relationship. And inside this diamond box, we will be writing the name of the relationship. That's what I am trying to say. कि जब आपके पास 2 एंटिटी हैं, team and player, तो आप इधर टीम है, इधर प्लेयर है, तो आप यहाँ टीम लिखेंगे, आप रेक्टेंगल बॉक्स में लिखेंगे टीम एज एंटिटी, और डायमंड बॉक्स में लिखेंगे रिलेशनशिप का नाम, और यहाँ होगा अगेन डायमंड बॉक्स, दिस रेक्टेंगल बॉक्स वेयर वी विल बी राइटिंग एज अ प्लेयर. So you need to write a proper relationship name. तो हम सिंपल कह सकते हैं कि टीम, this diamond box, inside box has, and this side we have players. So it will be clearly readable that team has players, something like that. तो जब भी आप डायमंड बॉक्स के अंदर रिलेशनशिप का नेम डिस्क्राइब करेंगे, तो उसमें ये क्लियरली होना चाहिए रिफ्लेक्ट कि दिस इज हाउ these 2 entities are related with. Team has a player, faculty assigned in department, student enrolled in course, something like that, right? Country has capital. अगर हम country और capital वर्ल्ड की different countries को लिखें इस तरफ entity में और इस तरफ बहुत सारी उनकी capitals को list करें, so the name of this relationship between these 2 entities, country name and capital name, it will be country has a capital, something like that. So whenever we define a relationship between objects, different entities, it is important to have a proper naming convention, naming proper word in the relationship box, right? So जब आप relationship define करेंगे between entity में, तो आपको ये ध्यान रखना है 2 चीजें कि what is the name of this relationship that should be mentioned inside this diamond box. That is one part. Second, what is the relationship ratio? Now that is something which is most important in the basically whenever we draw a diagram, ER diagram, it is very important to have mention about the relationship ratio, right? So let me take few seconds and ask you, what is the best possible example of 1:1 relationship? आपने जब जेई की तैयारी करी होगी तो इस सब चीजों के बारे में काफी कुछ पढ़ा होगा कि how to have defined this 1:1, 1:m or m:1 relationship. So what is the best example to define or to describe 1:1 relationship? Yes, post your answers. I'm waiting for the answers, so keep posting. Name and roll number. Okay. Any other example? So student and roll number. Okay, it is repeating now. और कुछ बताइए. Any name and roll number. 3 times. So go for any generic or real world relationship which we are facing or getting on daily basis. So one typical example of this 1:1 relationship is the country name, square of natural numbers. That's good. That's one of the good example. Employee and department. So it could be right. ऐसा नहीं है कि एम्प्लॉय और डिपार्टमेंट का ग्लोबली ये रिलेशनशिप है कि 1:1 होगा. वो दो डिपार्टमेंट मिलकर काम कर सकते हैं, राइट. पैन नंबर, दैट्स गुड, 1:1. So let's take this example of country name and its capital. So you can list the all countries of the world, 218 और 290, 220 जितने भी हैं, और उनके कैपिटल्स को अगर मेंटेन करना है, so it will be of 1:1 nature. That's for sure, right? So whenever we draw a diagram, क्या हम कह सकते हैं कि इंडिया में जो स्टेट है उनकी कैपिटल कुड बी 1:1? Yes or no? So if you want to list the state's name in the Indian states, and here we have their capitals. No. Why no? What are the exceptions of this relationship? Why no?
Chandigarh.
So because in at least one case we have this this exception, Punjab and Haryana. So two states, Haryana and Punjab, and having mapping with this one single relationship with one single instance. So अगर आप इस तरफ लिखते हैं कि entity name is state name, either capital name, so we have all the list of state, all the list of their capitals, and if you draw the relationship diagram, two object of this side will be going into the one single object. So it is not 1:1, it is what? M:1 or 1:m? So M will be which side? This side or this side? So which side M will be in case of state and capital of Indian state? M:1. So multiple states are converging to one side of one object, right? So multiple object of one side is going into the one singular. So many-to-one. Yes, that's many-to-one, right? So this is the first type. 1:1 is the first type, and naturally second type of relationship is 1:m, right? So one object of this entity, one object of, because in one entity we will have multiple instances or multiple objects. So one object of this entity will be relating to multiple entities. See, this is 1:m. So one entity will be mapping to the, one entity is mapped or related to the multiple entities, something like that. A reverse of it, it is 1:m or M:1, right? So we will have a detailed discussion on this relationship, कि कैसे उसको आप map करेंगे, define कैसे करेंगे, and contrast of these all three possible cases, 1:1, 1:m, and M:1. There is a third type which is called M:n. So from both sides, object of both side entity will have multiple relationship, right? From both ends. So what is the again? Let's take an example. Any real life world example where we can say it is M:1. So student courses. So one student enrolled into multiple courses. That's what the definition is, right? And each course is enrolled, or each course will have relationship with multiple students, right? So this is how you can basically define the relationship ratio. So there are various instances, or there are various ways of representing or showing the relationship. So in basically the notes which I have shared with you, there are the representations. So I have taken one typical example, that employee and manager. So we have two entities, employee entity and department entity, right? So in department entity we have department number 1, 2, 3, and likewise. And here we have various employees. So like we are working in the department or institute. So in the NIT we have various departments, and these various departments. So now we have list of employees. So there could be 100 or 200 employees. But if there is a rule like each department will be managed by one employee. So naturally, out of these 200, only 10 or 15 employees will be managing, right? Other employees are not. They are free from this relationship. Like here, we have E1 with E1 and E2. They are not having any relationship participation, or they are not having any participation in this relationship. Only E3, E5, E6, they are managing the departments even, right? And this relationship coming from, or basically we have derived this relation based on the given information on the data requirements, or maybe the SRS requirement, that only one person can manage the department. अगर ऐसा कुछ लिखा है कहीं requirement में, so this will be the relationship of relationship between the department and employee entities. ये आप ड्रॉ करेंगे तो उसमें होगा रेशियो 1:1, राइट? जो भी एंटिटीज के अंदर के ऑब्जेक्ट पार्टिसिपेट कर रहे हैं आपस में, दो दिस पार्टिसिपेशन इन द रिलेशनशिप इज ऑफ नेचर 1:1, right? That's one thing. Second, we have drawn this 1:m. So basically we have this way of representation, right? Employee works for the department. तो ये वो है जो हम कह रहे हैं कि जरूरी नहीं है कि हो सकता है इंस्ट्रक्टिव ने अलाउ किया हो कि एक एम्प्लॉय 2 डिपार्टमेंट्स में काम कर सकता है. इंडस्ट्री में तो होता ही ऐसा कि आप मल्टीपल प्रोजेक्ट्स में या मल्टीपल डिपार्टमेंट में काम करते हैं, राइट? सो E1 इज even works for D1 department, right? E2 works for, so here you can see from this side, each employee is working on one single department, right? But D1 is having multiple. So by looking at D1, you can say D1 में 3 लोग काम कर रहे हैं. D2 में only we have having 2 employees. D3 is having 2 employees, something like that, right? And if you go for the M/N, you can see the participation of each object. So here we have employee E1. He is much participated a relationship with project P1. So basically, he's working on project P1. But if you look at E2, employee E2 is working on a project P2 and by this way P3. So employee E2 is working on 2 different projects. Similarly, employee E7 is working on 2 projects, P1 and P3, right? So so basically each and every, so we have again 2 entities here, employee and projects. Here we have employee and department. Here we have employee and department. So for employee and department, we have 2 relationships. You can see. तो ये हो सकता है कि किसी जगह ऐसा हो कि हमें दोनों चीजें कैप्चर करनी है कि कौन सा एम्प्लॉय किस डिपार्टमेंट में काम कर रहा है, किस डिपार्टमेंट के काम करता है, वर्क फॉर है, और कौन सा एम्प्लॉय किस डिपार्टमेंट को मैनेज करता है. सो दीज आर 2 डिफरेंट टाइप ऑफ रिलेशनशिप. और ये शायद रिक्वायरमेंट में मेंशन होगा एक्सप्लिसिटली दैट यू हैव टू मॉडल दिस. So that's why we can have any type of relationship between 2 entities, and you have to understand the ratio of the partner of the relationship, as well as its nature. Definition जो हम कह रहे हैं कि employee manages department, employee works for the department. अब इन दोनों केसेस में entities सेम है, but relationship का नाम अलग है और उसका रेशियो अलग है, right? So अगर आप इसको precisely draw करेंगे, then only a person who is going to implement this database will have the clear idea कि actually में database में ऐसा है कि 2 entities employee या department में उनके बीच में ये relationship है, तो मुझे attributes ऐसे extra add करने पड़ेंगे to represent this relationship, right? And there is this 4th type of relationship which is called recursive. Recursive means या तो बार बार होना होता है, self call ही होता है, उसी को recursive बोलते हैं, I think. So this specific type of relationship referred as a recursive relationship because we are, so in case of this example and in case of this example, we have 2 different entities, employee and department, employee and department, employee and project. But there are very specific cases where in a relationship we have the same instance of entity both side of the relationship. Employee और बीच में relationship होगा। अब आप सोचेंगे ये possible कैसे है? ये तो वैसा इंसान है जो अकेला है दुनिया में और उसका अपने से self talk हो रहा है, self relationship हो रहा है, उस तरीके का है। So this is the typical case which happens in case of various organizational databases. जैसे आप assume करो कि कंपनीज जो होती हैं, कंपनीज में बहुत सारे एम्प्लॉयज के डिफरेंट सुपरवाइजर्स होते हैं, राइट? सो लेट्स से कि कंपनी में अराउंड 100 एम्प्लॉयज हैं एंड 100 एम्प्लॉयज में कुछ लोग प्रोजेक्ट मैनेजर हैं, कुछ लोग प्रोजेक्ट लीडर हैं, कुछ लोग सीईओ है, कुछ लोग सीटीओज हैं, अलग अलग पोजीशन में। तो अब आप उन्हीं 100 एम्प्लॉयज को डिफरेंट डेजिग्नेशन में प्लॉट करते हैं एंड नेचुरली for a few set of employees there will be a person who is acting as a project manager और उसके ऊपर क्या होगा, प्रोजेक्ट लीड होगा, फिर प्रोजेक्ट मैनेजर होगा, उसके ऊपर और डिफरेंट हायर पोजीशन पे होगा। So naturally there are few employees who are having these individuals assigned as a supervisors, right? तो अगर मुझे ये ड्रॉ करना है रिलेशनशिप कि employees supervising employee, so I need to keep this whole list of employee both sides, employees, 100 employees, 100 employees. Now we will be drawing this relationship between two same sets of employee. तो वो indicate करेगा कि this employee, so let's take this example again. So ऐसा कुछ कर सकते हैं आप कि employee E1 is having some kind of self relationship. तो इसको हम better way में समझ सकते हैं कि let's say कि employee E1 is supervising 4 employees, something like that, right? Employee E2 is being supervised by some other employee. So basically recursive relationship has a this nature that it will have the participation of same entity both side, that is obviously, और उसके बाद जो participation आएगा, participation तो इन्हीं तीनों टाइप में से कोई होगा कि 1:1 होगा। हो सकता है कि ऐसा कहा गया कि एक एम्प्लॉय का एक ही सुपरवाइजर हो सकता है, तो इट विल बी 1:1, बट ये हो सकता है कुछ केसेस में कंपनी कहा कि एक एम्प्लॉय 20 लोगों को मॉनिटर कर सकता है, सुपरवाइज कर सकता है। सो द पार्टिसिपेशन रेशियो इन दिस रिकर्सिव रिलेशनशिप विल बी 1:m, समथिंग लाइक दैट। तो रिलेशनशिप रेशियो तो वही रहेगा जो ms2n है या 1:m है या कि ms2n 1:1 जो भी है, बट रिप्रेजेंटेशन विल बी ऑफ डिफरेंट नेचर। सो व्हेनेवर वी सी recursive relationship instance in ER diagram, we will be using this kind of notion, right? तो इसको हम लेंगे जब अभी नेक्स्ट क्लास में एक टिपिकल एग्जांपल पिक करेंगे तो उसमें हम डिस्कस करेंगे। सो दैट्स व्हाट आई थिंक वी हैव डिस्कस इन डिटेल कि कैसे जो सो बेसिकली जो एलिमेंट्स है वो हमने डिस्कस कर लिए हैं। नाउ बेसिकली वी विल बी टेकिंग one or two basically real world scenario to understand or to discuss how to draw this whole ER diagram, right? So with this lecture I think I have shared the basic idea about identifying the entities, their attributes, and how to place a proper relationship ratio and a proper relationship naming into one relationship between entities, right? So with this I'm closing today's session. We have 1 or 2 minutes for questions. If you have, you can post your questions.